Welcome to today's lessons on function operations and compositions. This is part 2 of 2 videos that cover the topics under Standard 2.1b and Standard 2.1c. And they are also going to cover the topics that are taught in the lesson on Study Island called Function Operations and Compositions. So remember all of our study tips while we're going through here. Make sure that you're taking notes because you're going to need those to refer to as we go through problems. And then remember, if I go too fast, just pause and rewind, and you can even pause at the beginning of a question, work your problem out yourself, and then start watching the video again and see how you did, and that way you can get a gauge of how well you're learning this. In today's lesson, we're going to be looking at function division and function composition. And so after you watch both of these videos, then you're free to go ahead and work on your lesson.
So now they're asking us to divide the two functions that we're given. So I'm going to write that as a fraction because it's easier for me to see what I can cancel out when I do that. So I'm going to make sure you keep these absolute value symbols nice and straight. And I'm going to go ahead and write this as a fraction. Right off the bat, I don't see anything that I can cancel. However, I'm going to go ahead and factor what's inside the absolute value symbols and see if that helps out. So I'm going to go ahead and copy down my 24. And then I'm going to have to keep what I factor in absolute value symbols. So this is going to be x minus 3 and x minus 7 is what this top part factors to. And then I can factor out a 3, but I'm going to have to keep that in an absolute value symbol since it came out. And then this is going to factor, once I pull that 3 out, I'm left with x minus 3. Well, now that I have an absolute value of x minus 3 on the top and the bottom, I can go ahead and cancel those. And then here, the absolute value of 3 is 3, so I'm going to just write that as a 3. And now 3 and 24, the 3 cancels out, and then the 24 divided by 3 is 8. So once I do all my canceling, I'm left with 8 absolute value x minus 7, and I don't see anything else that I can simplify, so that's going to be my final answer, which is C. Here, they're asking us to divide the two functions and then evaluate it at -7. And once again, you can do it in either order. You can divide them and then evaluate, or you can evaluate and then divide them. So here, I am going to go ahead and evaluate each of these at -7. Remembering this when I'm substituting in to keep my -7 in parentheses. And then I'm going to do the same for g of x at -7. Okay, so here, -7 cubed is going to be -343. And then a minus a negative is the same as adding 7. And when I add 7 to that, I get -336. And then here, -7 minus 4 is -11. And now that I have my two answers, I'm just going to divide them. So -336 divided by -11. The negatives cancel, and that's the only simplifying I can do. So I'm just left with positive 336 over 11, which is letter A as my final answer. This question here asks us to divide these two functions, and then instead of giving us the answer in equation form, it wants us to find the graph that represents that equation. My first step is going to be to divide the two functions. So I put f of x on top of the fraction, like it shows here, and g of x on the bottom of the fraction. And so remember, a fraction bar is the same as division. And so now there's nothing I can straight up cancel there. There's nothing that all 5 terms have in common. So I'm going to go ahead and factor the top. And when I do that, I get x plus 4 times x minus 2 and then over x plus 4. And now, since there's multiplication between these two parentheses, I can cancel an x plus 4 and an x plus 4. And that just leaves me with x minus 2. So now I'm looking for which graph over here represents the equation x minus 2. Well, this minus 2, that's our y-intercept. That's the number by itself. So on the y-axis, I have two graphs that cross at negative 2. So now I'm going to look at the slope. The slope is the number in front of x where there's an invisible 1. So my slope is going to be positive 1 over 1. So that means it's going to go up 1 and then to the right 1. And the graph that has both of those points is graph A, which is choice A, my final answer. This next operation that we can do with functions is called a composition of functions. And it's basically a way of combining two functions. And so the first way that we could see this represented is instead of having an x in the parentheses, there's another function in the parenthesis name. Or you could have two functions and their names with a little circle in between them. Either way is the second function is going to be substituted into the first function. So here we're going to substitute f of x into g of x. So that means for every x in g of x, we're going to write instead x squared plus 6. So my first g of x, we first have an x cubed, so in parentheses I'm going to put x squared plus 6 cubed minus, and then it's another x, so in parentheses I'm going to put x squared plus 6 minus 210. And so now I just have to simplify this down, which here, this is, remember, this isn't, you can't just cube the x squared and cube the 6 because this is addition here instead of multiplication. If it was multiplication, you could do that, but because it's addition, this is actually x squared plus 6 times x squared plus 6 times x squared plus 6. So now I'm gonna have to FOIL that twice. So I'm gonna FOIL this first one. And when I FOIL that out, I get x to the 4th plus 12x squared plus 36. And so I already went ahead and combined the like terms after the FOIL also, and that's going to be x squared plus 6 also. And now I have to distribute here, and so that means I'm going to take the x to the 4th times both of those, and that's going to give me x to the 6th plus 6x to the 4th. And then I have to take the plus 12x squared times both of those. So that's going to be plus 12x to the 4th plus 72x squared. And then I take 36 times both, and that's going to give me plus 36x squared plus 216. And then I'm going to combine like terms. So there's only one x to the 6th term, so that stays. I combine my x to the 4th terms, and that gives me 18x to the 4th. Combine my x squared terms, and that's going to give me 108x squared plus 216. And now that takes care of this part, and now I have to look at this part. Well, this is a minus x squared plus 6, but it's in parentheses. So remember, when you're subtracting something in parentheses, it changes the signs of everything. So it's going to be minus x squared minus 6. And then I'm going to have my minus 210. So once again, I'm going to combine like terms. I only have one x to the sixth term, so I just rewrite that. I have only one x to the fourth term, so I rewrite that. But I do have some x to the second terms to rewrite, and that's an invisible 1 in front of that x squared. So 108 minus 1 is 107, so this is a plus 107x squared. And then I have some numbers to combine. I have 216 minus 6, that's 210, minus 210 is 0, so they all cancel out. So I'm left with my final answer here, which is letter C. This question here, we're working with the composition, that's what these symbols mean. And here it's giving us the answer and asking us which one of these is the correct problem. So we're going to have to work out each choice and see which one of these gives us this answer. So choice A, if I take that composition, G is second in my parentheses, so that means I'm going to substitute G into F. So that means anywhere there's an X in f of x, I'm going to replace that with all of g of x. So that means I'm going to have, instead of x, I'm going to have 5x minus 2, and then I have that plus 2 at the end. There's nothing to multiply or distribute by, so I can just go ahead and drop those parentheses and combine like terms. And so I combine minus 2 plus 2. Those, it's 0, so they cancel out, and I'm left with just 5x, which they're looking for 5x plus 8, so A is not my answer. So now I'm going to try out B. So I'm going to replace every x in f of x with the g of x, which is x plus 2. So that means I'm going to have 5, but instead of writing x, I'm going to write x plus 2 in parentheses, and then minus 2. And then I'm going to distribute the 5, which is 5x plus 10 minus 2. Combine my like terms. 10 minus 2 is 8. And that one gives me 5x plus 8, which is what they're looking for. So that's going to be my answer. But it's always a good idea, if this was an actual test, I would go through C and D and just make sure I didn't make a mistake and that those give me wrong answers also. So this one here, you're doing a composition again, but this time they're asking you to evaluate it at 7. So once again, you could work the composition and then evaluate that answer at 7. Or you can evaluate the G first, because it's second, and then take that answer and evaluate it in F. So as long as you do it in the right order, you can do it that way. So you always do the G second in the composition, so we're going to plug 7 in for g of x first. And so when we do that, we're going to have 4 times 7 plus 2. 4 times 7 is 28, plus 2 is 30. And so now, because it's a composition, we're going to take this answer that we got for g and substitute it into the first one, which is f. So now we're going to look at what is f of 30 at 4 over, and then 30 squared, because that was an x squared, minus 4. 30 squared is 900. 900 minus 4 is 896. And then 4 over 896 simplifies to 1 over 224, which is letter D, your final answer. I hope you learned something new today, and I'm so glad that you joined us.